Welcome to the Universe Unveiled, where we journey through the cosmos to uncover the deepest secrets hidden within the fabric of space and time. Today we explore the groundbreaking discoveries made by the James Webb Space Telescope, a marvel of engineering that has forever changed our cosmic perspective. This powerful instrument allows us to peer back into the dawn of time, revealing celestial objects that have remained hidden from us until now. From the very first stars that ignited the dark void to the complex planetary systems we see today, the universe is full of wonders. Gravity itself acts as a cosmic magnifying glass, bending light and allowing us to see objects that are far too distant for normal observation. Scientists and astronomers work tirelessly to analyze these images, piecing together the history of our universe, one pixel of light at a time. Among these faint pixels lies a discovery that has shaken the foundations of astronomy, a solitary star that shines from the edge of time. We call this ancient star Earendel, a name that evokes the morning star, shining brightly across the vast and dark ocean of the cosmos. It is the most distant single star ever detected, its light taking nearly 13 billion years to reach the mirrors of our telescopes today. While previous telescopes could only see the fuzzy glow of galaxies, Webb has the power to resolve this single point of ancient stellar light. Earendel is located within a galaxy known as the Sunrise Arc, which has been stretched into a long crescent by powerful gravitational lensing effects. Without the magnifying effect of the galaxy cluster WHLO-137 sitting between us, seeing such a distant individual star would have been completely impossible. This star existed when the universe was only 900 million years old, a time when the cosmos was still in its chaotic infancy. Data suggests that Earendel is a type B star, shining with a luminosity nearly 1 million times greater than that of our own Sun. Its surface temperature is scorching, more than twice as hot as the Sun, allowing it to emit light that can travel across eons. Researchers are now debating whether Earendel is a solitary giant or a binary system, with two stars orbiting each other in a close dance. Statistical models suggest a high probability that Earendel has a companion, though the immense distance makes it difficult to separate their individual light signals. There is a thrilling possibility that Earendel could belong to population 3, the very first generation of stars formed from primordial hydrogen and helium. If confirmed, this would be the first direct detection of such stars, offering a pristine window into the chemical composition of the early universe. James Webb continues to gather spectroscopic data, hoping to find the chemical fingerprints that will reveal the true nature of this distant cosmic beacon. Leaving the distant edges of the early universe, we turn our gaze closer to home, focusing on the majestic jewel of our solar system. For centuries, we have observed Saturn in visible light, admiring its golden hues and the complex structure of its magnificent and icy ring system. However, the James Webb Space Telescope has revealed a completely new side of Saturn, capturing it in near-infrared light for the very first time. In this wavelength, the planet appears incredibly dark because methane gas in its atmosphere absorbs almost all sunlight falling upon the high-altitude clouds. The icy rings, however, contain no methane, so they reflect sunlight powerfully, appearing as glowing bands of light encircling the shadowed gas giant. The image also captures 3 of Saturn's moons, Dione, Enceladus, and Tethys, appearing as bright, distinct points of light in the dark void. This unique contrast allows scientists to study the intricate details of Saturn's atmosphere and the varying densities of its magnificent ring system particles. By peering through the haze, we can detect deep atmospheric structures and seasonal changes that are invisible to telescopes operating in standard visible light. Webb has also focused on Enceladus, capturing massive plumes of water vapor jetting out from its surface, hinting at a subsurface ocean below. Returning now to our own blue planet, we investigate a mysterious, invisible shield that protects all life from the harsh radiation of space. However, there is a growing dent in this armor, a region known as the South Atlantic Anomaly, where the magnetic field is weakening. This anomaly stretches from South America to Africa, creating a zone where charged particles from the sun penetrate deeper into our planet's atmosphere. Satellites passing through this region often experience technical glitches, data corruption, or even complete shutdown due to the intense bombardment of high-energy particles. Even the International Space Station is affected, requiring extra shielding and precautions to protect astronauts from radiation exposure when orbiting over this specific area. To understand the cause, we must look deep beneath our feet, nearly 3,000 kilometers down to the boundary between the mantle and core. Scientists have discovered two colossal structures of dense rock, known as large, low shear velocity provinces, lurking deep within the Earth's lower mantle layer. The structure beneath Africa is particularly massive, and its high density disturbs the flow of molten iron in the outer core, generating the field. This disruption in the geodynamo creates patches of reversed polarity, weakening the overall magnetic field strength in the region above the South Atlantic. Some theories suggest these blobs are remnants of an ancient planet named Theia that collided with Earth billions of years ago, forming the Moon. The dense fragments of Theia may have sunk to the bottom of the mantle, remaining there as silent witnesses to a violent cosmic collision. Observations show the anomaly is expanding and splitting into two lobes, posing increasing challenges for future space missions and satellite constellations in low orbit. We now travel 2.5 million light-years away to the Andromeda Galaxy, where amateur astronomers have made a discovery that baffled professionals. A dedicated team of amateur skywatchers discovered a massive, faint arc of gas right next to the galaxy, something major telescopes had completely missed. This structure, named SDSO-1, is a giant arc of ionized oxygen that emits a faint blue glow, invisible to most standard broadband surveys. Professional surveys often optimize for speed and depth, overlooking such large, diffuse, and faint surface brightness features that require long exposure times to capture. The arc shines primarily in the wavelength of doubly ionized oxygen, suggesting it is being energized by a powerful source of radiation nearby. Scientists are investigating whether this arc is the result of a shockwave from the galaxy's halo or a remnant of a past interaction. This discovery highlights the vital role of citizen science, proving that you do not need a billion-dollar telescope to make significant cosmic contributions. In the constellation of Orion, the red supergiant Betelgeuse has captivated observers for centuries, but recently it began behaving in a very strange manner. In late 2019, Betelgeuse suddenly dimmed significantly, losing 2/3 of its brightness and sparking rumors that it was about to go supernova. High-resolution images revealed that the southern hemisphere of the star had become obscured, leading scientists to scramble for a logical physical explanation. We now know that Betelgeuse experienced a massive surface mass ejection, blasting a chunk of its own material out into the surrounding space. As this ejected gas moved away and cooled, it condensed into solid dust particles, forming a thick cloud that blocked the star's light. From our perspective on Earth, this dust cloud acted like a cosmic curtain, temporarily dimming the great star before eventually dissipating into space. Betelgeuse is now recovering, but it continues to pulsate, reminding us that even the most stable-looking stars are dynamic and volatile entities. Our quest for understanding extends beyond stars to the worlds that orbit them, in the eternal search for life elsewhere in the universe. One promising candidate is TOI 700d, an Earth-sized planet located in the habitable zone, where conditions might allow for liquid water to exist. This planet orbits a cool red dwarf star, and while it is tidally locked, its atmosphere could potentially distribute heat to support life. Another intriguing world is Teegarden B, which has one of the highest Earth similarity indices, suggesting a stable environment for biological evolution. Astronomers have also defined a new class of exoplanets called Hycean worlds, which possess vast liquid oceans beneath massive, hydrogen-rich atmospheres. These worlds are larger than Earth and hotter, but their oceans could still harbor microbial life forms adapted to extreme pressure and temperature. The James Webb Telescope recently detected traces of methane and carbon dioxide in the atmosphere of K2-18b, a potential Hycean candidate. Most intriguingly, there were tentative hints of dimethyl sulfide, a molecule that, on Earth, is only produced by living organisms in the ocean. The diversity of planets out there is staggering, proving that our solar system is just one of countless configurations in the galaxy. As we continue to gaze into the heavens, each discovery brings us one step closer to answering the ultimate question: are we alone? With future telescopes and missions already in planning, the next decade promises to unveil even more secrets of the universe's grand design. Thank you for watching the Universe Unveiled. Join us next time as we continue our eternal quest to understand the infinite cosmos. Remember to like and subscribe for more journeys into the deep unknown. Until then, keep looking up at the stars. Goodbye. Let us take a moment to reflect on the power of black holes, the gravitational anchors that hold entire galaxies together in space. These cosmic monsters are not just destroyers. Their energy jets can trigger the formation of new stars across vast distances of space. We revisit the pillars of creation, where the James Webb Telescope has revealed young stars forming inside the dense, dusty clouds. Comets, the icy wanderers of our system, carry the pristine ingredients from the formation of the solar system billions of years ago. On Mars, our rovers continue to drill into ancient lake beds, looking for fossilized evidence that life once thrived on the red planet. Europa beckons us with its icy shell, hiding a global ocean containing twice as much water as all of Earth's oceans combined. Titan offers a bizarre reflection of Earth, with rivers and lakes, but flowing with liquid methane instead of water under orange skies. When massive stars die, they go out with a bang, creating supernovae that forge the heavy elements essential for life itself. The cores of these dead stars can become neutron stars, objects so dense that a teaspoon of their material weighs billions of tons. When neutron stars collide, they shake the very fabric of spacetime, sending gravitational waves rippling across the universe to be detected by us. These violent collisions are the cosmic forges responsible for creating most of the gold, platinum, and other precious heavy metals in existence. Yet visible matter makes up only a tiny fraction of the universe. The rest is mysterious dark matter holding galaxies together. Even more mysterious is dark energy, an unknown force that is accelerating the expansion of the universe, pushing galaxies apart faster and faster. We listen to the radio whispers of the cosmos, hoping to catch a signal that proves intelligence exists elsewhere in the galaxy. Our robotic ambassadors like Voyager have left the solar system, carrying messages from humanity into the eternal silence of interstellar space. From the depths of space, our home is but a pale blue dot, a fragile oasis of life in a vast arena. The beauty of our planet is unmatched, with dancing auroras reminding us of the dynamic interaction between our world and the sun. Our star is a dynamic engine, and understanding its cycles is crucial for protecting our technology-dependent civilization from solar storms. Mercury, the closest planet to the sun, endures extreme temperature swings, a scorched world stripping away its history layer by layer. Venus serves as a cautionary tale of a runaway greenhouse effect, transforming a potentially habitable world into a hellish volcanic landscape. Between Mars and Jupiter lies the asteroid belt, the leftover building blocks of the solar system that never coalesced into a planet. Uranus rolls through its orbit on its side, likely the victim of a massive collision in the distant past that tilted it. Neptune, the farthest planet, is a world of supersonic winds and icy storms, guarding the outer boundary of our planetary neighborhood. Beyond Neptune lies the Kuiper Belt, a realm of frozen dwarfs like Pluto, holding secrets from the very birth of our system. Surrounding us entirely is the theoretical Oort cloud, the distant reservoir of long-period comets that occasionally visit the inner solar system. Our moon was born from fire and chaos, but it settled into a peaceful orbit, stabilizing Earth's tilt and enabling life. The cosmic coincidence that allows the moon to perfectly block the sun during an eclipse is a spectacle unique to our planet. Galactic collisions are destructive but creative, triggering massive bursts of star formation that light up the universe with new energy. Active galactic nuclei are the brightest continuous sources of light in the universe, powered by the insatiable appetite of supermassive black holes. Quasars act as lighthouses from the early universe, allowing us to study the intergalactic medium between us and these distant ancient beacons. Edwin Hubble taught us that the universe is expanding, changing our static view of the cosmos into one of dynamic evolution. The cosmic microwave background is the afterglow of the Big Bang, a fossilized map of the universe when it was just a baby. We are made of star stuff. The carbon in our cells and the oxygen we breathe were forged inside the hearts of dying stars. The Crab Nebula stands as a beautiful remnant of a supernova observed by humanity nearly 1,000 years ago, expanding ever since. Globular clusters are ancient cities of stars containing some of the oldest stellar inhabitants in our galaxy, orbiting the galactic center. When stars like our Sun die, they create planetary nebulae, beautiful shells of gas that enrich the galaxy with new elements. The remaining core becomes a white dwarf, a stellar corpse that will slowly cool and fade over trillions of years. In binary systems, a white dwarf can steal life from its companion, leading to explosive novae that light up the dark skies. At the heart of our own galaxy lies Sagittarius A star, a sleeping giant that dictates the orbits of the central stars. Missions like Gaia are mapping billions of stars, creating a dynamic, three-dimensional census of our galactic home with unprecedented precision. Our solar system resides in a quiet spiral arm, a safe harbor far from the chaotic and dangerous center of the galaxy. Giant bubbles of energy extend from the galactic center, evidence of a massive outburst from our black hole millions of years ago. Our galaxy is a cannibal, consuming smaller dwarf galaxies and leaving behind streams of stars as evidence of its gravitational dominance. The Magellanic Clouds are our constant companions, satellite galaxies that are slowly spiraling inward to eventually merge with the Milky Way. Trillions of years from now, the last stars will burn out, leaving the universe in a state of cold, eternal darkness. Some theories suggest our universe is just one bubble in a vast multiverse, each with its own unique laws of physics. String theory attempts to unify gravity and quantum mechanics, proposing that everything is made of tiny, vibrating strings of energy. The discovery of the Higgs boson confirmed how particles gain mass, a crucial piece of the puzzle in the Standard Model. Neutrinos are ghostly particles that pass through Earth by the trillions every second, barely interacting with matter, carrying secrets from stars. Buried in the Antarctic ice, detectors hunt for these elusive particles to pinpoint the most violent, high-energy events in the universe. Humanity is preparing to return to the Moon, not just to visit, but to stay and build a gateway to Mars. A permanent lunar base will serve as a testing ground for the technologies needed to survive on other worlds deep in space. The journey to Mars will be the greatest challenge of our time, testing human endurance and ingenuity like never before. In the distant future, we might even dream of terraforming Mars, turning the red dust into a second blue home for humanity. While faster-than-light travel remains science fiction, theoretical physics explores the possibility of warping space to reach the stars. Solar sails could allow us to reach nearby stars within a human lifetime, riding powerful laser beams across the interstellar void. Alpha Centauri invites us as the nearest star system, a potential destination for the first interstellar probes launched by humanity. Proxima b orbits in the habitable zone of our nearest neighbor, raising hopes that life might exist right next door to us. If the universe is teeming with planets, where is everyone? The Fermi paradox remains one of the most haunting questions we face. Perhaps there is a great filter, a challenge so difficult that few civilizations survive it to travel among the stars. Our existence is fragile. We must cherish and protect our only home while we reach out to the unknown. We must also manage our orbital environment, as space debris threatens to trap us on our own planet if left unchecked. The resources of the solar system are infinite, Mining asteroids could save Earth's environment and fuel our expansion into the galaxy. Harvesting the unlimited power of the sun from space could solve our energy crisis and power a clean, green future. Visionaries dream of rotating habitats where millions of people could live in orbit, expanding humanity's footprint beyond the surface of Earth. As we venture further, we may evolve, adapting biologically and technologically to the unique challenges of living among the stars. Artificial intelligence will be our partner, piloting ships and analyzing data far faster than any human could ever hope to achieve. The universe is violent and beautiful. Stars are shredded by black holes and tidal disruption events that light up galactic centers. On the largest scales, the universe looks like a neural network, a web of matter and energy stretching across infinity. Between these filaments lie cosmic voids, vast expanses of nothingness that make up the majority of the volume of the universe. We live in Laniakea, a supercluster of 100,000 galaxies flowing together like a river through the cosmos. Something massive, known as the Great Attractor, is pulling our galaxy and thousands of others towards it, hidden behind dust clouds. Looking up, we feel small, but our ability to comprehend this vastness makes us significant in the grand scheme of things. We must inspire the next generation of explorers, for they are the ones who will take the next giant leaps for mankind. Space exploration unites humanity. Up there, borders disappear, and we work together as one species representing our planet Earth. On the ground, giant new telescopes are rising, ready to complement our space observatories and pierce the veil of the night. Light is our only messenger. By decoding its hidden colors, we unlock the composition, speed, and history of the entire universe. We have entered the era of multi-messenger astronomy, seeing, hearing, and feeling the universe in ways never before thought possible. From the first stars to alien oceans, we have witnessed the incredible variety and beauty that the cosmos has to offer. What discovery excites you the most? Let us know in the comments below and share this video with fellow space enthusiasts. Thank you for being part of our journey. Your curiosity fuels our passion to keep exploring the final frontier together. Click here to subscribe and watch our other videos. Until next time, this is the Universe Unveiled, signing off.